nitrogen dioxide, sulfur dioxide, and particulate matter 2.5 and 2.10. So this data can be accessed from the Airsense database through the website and the smartphone application, alongside environmental data from external APIs. And users will receive alerts from the mobile application when contaminant levels are too dangerous. And here we have our device prototype. And basically, this is our device currently. And it consists of two sensors. We have our particulate matter sensor, and we have our all-in-one sensor, which measures nitrogen dioxide and carbon monoxide. And it's all connected using a solderable breadboard. And it's housed inside a printed 3D container, and it's very durable due to that. And due to its small size, it can also be converted into a keychain, which can be hung on a jacket, on luggage, on a handbag, anything really. For our original prototype, we actually wanted to keep it inside a backpack with a mesh panel. And this backpack will allow airflow within the device, and so we can measure the air quality more effectively. And we have, basically what we use to get the data is we have RF signals, Bluetooth, or we use Wi-Fi. And right now we use off-the-shelf technology for our sensors and for our microcontroller, but in the future we'd like to use printed circuitry, and this will make it even more efficient and even smaller. And of course, the cost will be reduced as well.
And website pull the data from the database, and it display the air contaminants in like that on the heat map. And the environmental information such as like weather conditions and humidity and temperature will also displayed in the heat map. And
is this a web-based?
Yeah.
Okay.
Yeah, I will show it later. And also we can search based on the city's name, like that, the list of. And when it is the global scale when we incorporate the big data after.
Okay, similar to the website, the smartphone application is capable of pulling all the data from the database and display this information in a tabular or heat map format. And it also features, the mobile application also features a user login, where the user of the device can track their personal exposure to air contaminations and receive alerts when the contaminants are at an unhealthy level.
In this our proposal, there's 4 different components. The first of all, like Airsense device, and externally hosted database, and cloud with the environmental API, and the web page, and the mobile application. I will explain the process of our project. So the air flew the device, so it detected the air contaminant automatically. So it span the data from to the clouds, and we can read the data set, like value of the air component and GPS location to the website and mobile application, and we will display all of the information, AQI and the temperature, humidity, and all of these.
So the technology involved in our project, we have an interdisciplinary approach for our project. So we use computer engineering and electrical engineering to build our hardware for all our circuitry. And then we have computer science for all the programming for the database, the website, and the mobile application. And we also use various modern technologies, so our device could be considered a technology integrator. So we have IoT, basically we're getting all our information from the sensors, so we're putting it into a database, which is the cloud network. And we have wireless communications between the phone, between the laptop, between our device itself. And we're also using big data for our database and cloud systems. We have a lot of values coming in, and we crunch all that data. And you have cloud computing, of course, for our IoT. It's combined with IoT. And then we are also using mobile application. We have Android Studio. So that's what technology we're using.
So air pollution has many negative impacts around the globe. Like it also contributes to many illnesses, stroke, and heart disease, even death. So in United States, many cities are actually struggle to the EPA standards of acceptable levels of air contaminants. So yeah, so therefore the easily accessible, affordable method to monitor level must exist. So therefore, Airsense.
So our project impacts like individually, like health problem will directly access with the air contaminants, like pollutants level. So the model will encourage like company to build like a smaller process sensor, because in our prototype is like that size, but our goal is that this keyboard size. Yeah, we hope that. And user can provide information about the air pollutant level. So this is give a like sense of the accomplishment. It's kind of game. And researcher can use the data to make predicts about the pollutant level. We will give this value, like this system, to the researcher, so researcher can solve the air pollutant levels and they can research a lot of things from this prototype.
So our business plan, which is technically our own plan because we had plans to hire ourselves to complete the project. So it takes around 19 months to complete, and social media will be used throughout this entire time period to raise awareness. So we will have Facebook, Twitter, YouTube. So we want to keep posting continuously, and we want to have like fun giveaways. We want to make people engaged, and we want to make sure that they know about the impacts of air pollution, about air contamination, how to keep the earth green. And we also aim to partner with environmental interest groups such as the United Nations Environment Program and the CAAC, and hopefully they will be attracted to the cause and they will help further our cause throughout the globe, basically. So the first 200 units, so our plan initially is to build 200 units. So we want to send all those units to universities all over the world. So we want the students and the faculty to be able to use this device and to get the data and to populate our heat map, and this will lend credibility to our device, and it also helps people be more aware. And we also want to have a Kickstarter program to help fund that program. And here is our actual business model. So 19 months, and we'll be spending the entire 19 months doing community relations simultaneously with all these other tasks. So we have 12 months for our fundraising Kickstarter. We have 2 months to order our materials, to get our staff together, and we have 4 months for basically development and testing of our device. And then we have, because marketing is such an important part of our project, we have allocated 2 months for branding and advertising of that segment. And then of course program maintenance will start immediately after we finish the development and testing of our product.
Okay. So the total cost of building 200 units is 256,000, and this is split into labor cost, like a material cost and operational cost. So for the labor costs were estimated using average pay for engineers, computer scientists, office workers, and designers. So each worker will work for 40 hours per week. So it comes out to be 160,000. So material costs were estimated using price of the shelf, sensors, and microcontrollers. But it could be cheaper if the circuits were printed.
So first the MSRP probably around 1,200 per unit.
Firstly, you
Oh,
200
No, the total
Yeah,
for
the
the
total.
entire thing.
entire
Yeah.
things.
So we summed everything together.
Yeah.
Yeah. Then it's a first 200 unit is around 250,000, right? Cost.
Oh no, it's the combination of $160,000, $36,000.
Including labor
Yeah,
cost.
yeah,
But
yeah.
for MSRP, when you sell the product,
Mhm.
so roughly divided by the number of unit,
Mhm.
right? Then that will be 1,000, right? So
Well,
that's
it
it.
could be cheaper.
Yeah, it could be
It is
cheaper.
way
Yeah, I
It
think
could
cheaper.
make it cheaper.
Yeah.
If you mass product, it's probably higher than that, like the 1,000 or the 10,000, by considering your target market.
Mhm.
And your labor cost and the material cost will not be increased a lot, right?
Mhm.
Okay.
And so the material cost is 36,000. So operational cost includes like office living, food, electricity, and heating bills, etc. So that is the total is 50,000.
I think the more like the first 19 months, the business is the R&D part is a lot, right? So to develop and design.
And I will explain the safety. So OSHA standard will be like followed by the whole workforce. So right to know regulations, understand emergency like response equipment operations. When wiring circuit, the team will wear non-conductive gloves and rubber shoes, and surface will be non-conductive with like when we can detect the like fire hazard. So a safe manual will be provided for each Airsense device will be included.
Oh, you went backwards.
Thank you.
Okay, there is you have a demonstration?
Yeah.
So, question, is it after demonstration or what do you want?
We could take questions now if you'd like.
Yeah.
Okay, so my question is I have two questions. It's very nice. Nice the presentation. I think based on my experience, one of the closest to the really commercialization product from the senior project. So, but to do that, the one thing was you need to calculate precisely what is the cost and what is the profit margin. You should have the profit, right? Then I cannot see that part. And then who will be the type? The first 200 units is more like the provide to the researcher or other university you said, but for the mass produce, so definitely you need to consider your target market, like the education, the school district or something like that, and then you can sell the mass product. And then you can calculate the more precisely what is the cost for each. I think the 1,200 may be a little bit high. And my question is, another question is the size also. So you already realized that, everybody knows that it will be smaller, but what about the box itself? Does it affect the accuracy of your sensor? For example,
No,
the
no,
circulation,
inside.
the inside, did
We
you
tested
test
it,
with
yeah.
the
Yeah,
box,
we tested
without box?
with and without.
Yeah,
It's the
yeah.
same.
It's the same?
Yeah.
Okay. So because in case of the pollution level, if it's not circulate, the inside and outside, it may be different, the accuracy. But if you already
Yeah, we
tested,
tested,
yeah,
yeah.
then, so that is okay. Then also, but if that is okay, it's fine. But otherwise, you need to consider the material of the box also. Okay. And right now, what is the power source?
Well, to show the
Yeah.
data, we have to connect it to the laptop
Connect
to
it,
like show it. But we have a portable like power source. We could
No.
connect a portable.
Did you test any the battery or?
We haven't tested the battery
Yeah.
yet.
So, and also in case you use the battery, you should have the regulator also. And then are you using the Raspberry Pi or
No,
I
Node
don't know.
MCU.
Yeah.
which one?
Node MCU.
Which I do not know. What is the power?
I'm not sure.
5.7 or?
I think it's 5 volts.
5 volts.
Yeah.
Okay. So then you need to think about such a power. Definitely the battery should be also rechargeable, and we can make the better quality of them. Any other question? Okay, go ahead for your demonstration.
So we have hotspot on?
Yeah, I will.
Alright.
Are you going to change the projector to one of your?
Well,
It
we
will
have,
be
we
better?
have to have like simultaneously.
Yeah.
Yeah,
okay.
it's kind of
Show-
IoT.
Yeah.
Okay.
We can come
Yeah.
closer. Like everyone can come closer if they want. Like if
If
they
you want
want.
like
Yeah.
Okay, go ahead.
Takes a little while because my laptop is old. Just have to wait for a bit because my laptop is old. Sorry. Oh, there you go. See, these are the readings coming in right now. and then it's
I
automatically updated onto our
Cloud
Yeah,
database.
to the database.
AWS.
What is the durability of the reliability of the sensor? So if I shake, so any changes or
It shouldn't unless the wires get.
did you test it? Because you said it will be the hand on the backpack, something like that. The keys are running around. So you need to think about the durability and.
Yeah.
Eventually, it will be a
Yeah,
printed circuit. I mean, this cannot be portable. You know, yeah.
So
Here
then
is
we
the-
have our
The data
database. So it,
to the database.
What kind of database are you doing?
AWS.
Yeah,
AWS.
Amazon
Yeah,
Web
the
AWS.
Services.
database.
Okay.
But have to plug out.
Oh, sorry.
Yeah.
Yeah, sorry.
Stop it.
And
Yeah.
then
And then we show the data
on the
Yeah.
website.
on the website, and it will display like
Yeah.
And a heat
Here's
map.
on the heat
Uh,
map. I
it's
just
okay.
we only detected like New Mexico and here, so
Yeah.
I just put it down like some
So-
fake value in
so
the other
idea,
cities.
The idea, let's say that over years we'll have 1 million devices all over the world.
Yeah.
Yeah.
So collecting the data everywhere,
Mhm.
and you know it's gonna go to the cloud. So if let's say that you are visiting Bridgeport, so
Yeah.
maybe in Bridgeport there is about 100 sensors of these. So
Yeah.
you could collect the average. You could put the range, so within 5 miles, 10 miles, 20 miles. Okay. So this will be also, it will calculate the GPS coordination. It will calculate the temperature, the wind. So scientists could also correlate, is the wind increasing the contamination, reducing it, the temperature, and all of
Yeah.
that. So it's like a heat map for the whole world.
Mhm.
Over many years it will be populated. So could also go, for example, in the past 10 years, how it was changed in 10 years, in 1 year, in 2 years, and all of that. So
Yeah.
that's only a prototype,
Mhm.
elementary prototype. So
We hope that global scale like, when
Yeah.
we collect all of the
All of
words,
them,
so
yeah.
Yeah.
it can show up display in one's time. So it would be really helpful for
Yeah.
all of
and
the
this is a
peoples.
true IoT device. IoT device has 3 levels. It has a sensing, okay, then the
Cloud.
communication,
Yeah.
and then after that you have the cloud computing, the processing. All right. So that's what IoT. IoT is all about collecting data, processing, or using in real-time applications. All right. So it's not only a mobile application. It's like a whole IoT application.
Yeah.
Yeah.
Excellent.
Yeah.
Yeah.
Thank
Thank
you.
you. Thank you.
Thank you so much.
Thank you. Thank you.
Thank you.